start to come and check your homework. Page 3. And everybody's out of time. They had certainly enough class time yesterday. Thank you. And while you're at it, you can grab your Chromebook so that way you can take your quiz, which will be posted momentarily. Thank you. Please make a note. Assignments for tomorrow. There are 2 of them. The first assignment that you need to do is page 6 in your packet. Page 6 will be homework for tomorrow on mass and weight. Just page 6. Then we're also going to be working on a lab once we finish taking our quiz. If your lab is not turned in before you leave today, you will need to finish it tonight. I will be collecting it at the start of class if you don't turn it in today. Okay? All right, let's check over your answers to page 3 before we take the quiz. So number 1, inertia is the tendency of an object to resist a change in motion or to accelerate. Number 2, the amount of inertia depends upon mass. Number 3, we talked about this. This was the exact same question out of your packet. What difference does Shirley observe? She notices that the more massive brick has more inertia, therefore it is harder to push. Number 4, it wouldn't matter where she was. She would see the same thing no matter where she was located, because an object with more mass will always have more inertia. And inertia is a tendency to resist acceleration. So the more massive brick will always accelerate less. Number 5, with more mass, it's harder to change your direction. So the moose, therefore, can't catch you. Number 6, inertia is D, the tendency of an object to resist change, keep doing whatever it's doing. And lastly, number 7, C has the smallest inertia, then D, then A, and then B. Any questions? Fantastic. Please put your packet away. You may not use it on today's quiz. Let's see if your quiz has posted for you to take it. Nope, doesn't look like it has. So let me push it out to you. All right. Oh, it's currently being posted, it says. Is it there? Yes? Okay. All right, go ahead and take the quiz now for Unit 6B, please. 6B, Newton's first law. When you're done with the quiz, put your Chromebook away. The only 3 items you will need for the duration of our class are a pencil, a ruler or straight edge, and a calculator. Pencil, ruler, calculator. Okay, when you get your lab worksheet, on the top, of course, in pencil, please write your name and the lab number. This is lab number 14. Now, the purpose of this lab is to do the following things. You're trying to prove to me that you can do these things, that you can measure the weight of a known mass with a spring scale, that you can then create a graph using proper graphing techniques of weight versus mass, that you can explain what the slope of a graph of weight versus mass represents. So we talked about that in class yesterday. And finally, can you determine gravitational field strength from a graph? So here's what you're going to do in the lab. I'm going to be putting you into groups. And the first thing you're going to be doing is using what's called a 20 Newton spring scale. You haven't used a spring scale with me before, so let me describe how it works. And what I'm going to do is I'm going to turn my camera this way because otherwise it doesn't work quite so well. So this is a spring scale. Let me see if I can focus it on the text that's here. Okay, now why is it called a 20 Newton spring scale? Well, you can see on the left side, that's where it's going to read newtons for us, that this goes up to 20 newtons. It won't go any more than that. That's why we call it a 20 Newton spring scale. Why is it called a spring scale? Because inside of it, when I pull down, can you see what's in there? There's a spring. So it's a scale that uses a spring to measure things for us, forces in particular. When I pull on the bottom of this, you can see the spring elongates and it tells me how much force I was exerting in newtons. The first thing you and your group will need to do is zero this out. And the way it zeroes out is using this metal tab on the top. It slides up and down. So what you're going to want to do, and I can't really demonstrate this on the camera, so please look at me. What you need to do is put this at your eye level. So your eye is looking straight at that scale. And what you want is the bottom of that metal tab, when you hang it straight in front of your eye, should read 0. If it's not, you're going to slide it up or down like I'm doing right now. So that one to me looks zeroed out. It's hard for me to show you that on here because the camera's angled a little bit. Okay, so just trust me, I zeroed this out. The bottom of the metal tab should be at 0 when it's at your eye level. Don't look above or below. And you can hold it from its side or you can hold it from the top. But when you hold it from the top, it's harder to adjust the metal tab. That's just for calibrating it. Then what you're going to do, you can see it tells you what to do. It tells you here, once you have your scale, to measure the weight of the masses in this table. So I've given you several different masses that I want you to measure the weight of. How do you measure the weight? Just hang the mass on the scale. Just let it hang. You don't want the mass bobbing up and down. Just let it hang. To hold it by the metal ring on the top, put the mass on the bottom, and read it as best you can to the nearest tenth of a Newton. These values are then going to go here in your table. Then you're just going to follow the steps in the analysis to complete the lab. I'm not going to show you how to do it. Read it and do it. All the directions are there as to what you need to do. And you'll be working in a group, so work together as a group to help each other. Okay? It's a pretty straightforward lab. Now, when I give you the masses, I'm only going to give you 3 masses. You see that there's a bunch of them? The 3 masses I'm giving you are a 200 gram, a 500 gram, and 1,000 grams. That's it. From those 3, you should be able to make all of these combinations total hanging on the scale. Okay? Any questions for me? Yes, Olivia? What does it say in step 1? Got it? Okay, that's what I'm saying. I don't really need to tell you what to do. It's all written there. You just have to read it carefully. Okay? And between the people in the group, you should be able to figure it out based upon what everything says. And you know what I expect to see in the lab. It tells you, but think about what would Ms. Famoso want me to show in order to get full credit. You know. You're not dumb. You've been paying attention since September 5th, our first day of school. You know I'm picky about things. So, okay, let me break you into groups. We're going to have, I think, groups of 3. So 1, 2, 3. I'm going to have the 3 of you work together. You're going to want to get around one desk. So Aiden, let's do this. Bring your chair around so you can face Maddie and Jada. Okay. Then I'll have the 3 of you work together. So Adrian, why don't you bring your chair around and sit over here. I'm going to have the 3 of you work together. So, I don't know, one of you should swing around on the other side. Olivia, I'm going to have you work with Wallace and Mo. And then I guess I'll have you guys work in 2 pairs. Okay, you can work as a pair with each other. And that should be good enough because it's pretty easy to do it. You should be able to help each other. All right, let me get you the equipment you need. Hand out the scales first. Remember, you need to calibrate. Calibrate them first. Calibrate the scale first. Calibrate your scale first. And I'll get you some masses. So you can start getting your data. Which one it is. Why are none of these labeled? 3 masses. All right. This one is 500. You want to make 500 grams. This is 500. You can write 500 on that if you want. This is 500. If you want to write 500 on that, so you This is 500. That's 200. You can write 500 on that if you want to remind you.